Let me give you an update on the work we've been doing using satellite remote sensing for water quality assessments in Minnesota, and specifically how we've automated the image processing procedures with the collaboration of David Porter at the Minnesota Supercomputing Institute. In Minnesota, we have a good field monitoring program for water quality variables. At the same time, we have satellites regularly collecting imagery. So what we do is we find some good clear imagery, link up the field measurements within a few days of the image, build a statistical model of that relationship, apply that model to all the lakes on an image. Do that for enough images, we come up with the water quality for the whole state. Using those procedures, we've completed 9 statewide assessments since 1975, with over 10,000 lakes included in each of these assessments. These are at around 5-year intervals. We use that for analysis of spatial and temporal trends and causal factors. One thing we did back in 2002 is we made all of our data available on an online Google Earth format lake browser, where people can zoom in and get information about their lakes. It's been very popular with thousands of unique visitors come to get their information every month. Having water clarity at 5-year intervals has been great. It's been real popular, but if we really want to improve lake and fisheries management, we need more water quality variables more often. And that's where we're going with these new sensors that are available. They have higher spatial, spectral, radiometric, and temporal resolution. Not only can we map water clarity, we can also measure the factors that control water clarity. Things like chlorophyll, suspended materials, and color dissolved organic matter. The spectral characteristics of the sensor determine how well it can measure different water quality variables. And for these 2 satellites, Landsat 8 and Sentinel-2, Sentinel has additional red edge bands that are very useful for chlorophyll measurements, picking up this peak here. And so for Landsat, works really well for water clarity for CDOM, and for Sentinel has a little bit better for the chlorophyll. Another big advantage of the Sentinel-2 satellite is the high temporal coverage, which I'll demonstrate here with some imagery from August of 2019. As you can also notice, there's lots of cloud cover in Minnesota, and so we're going to need a lot of coverage in order to cover the whole state really well. Most of these images I would not use for my manual techniques, so automation really helps. And so basically having this imagery, an opportunity to build a near real-time water quality monitoring system, and that's what we've done here. We have all this new data available, downloaded to the ground stations. We can have a machine-to-machine access, pull it into the Minnesota Supercomputing Institute. Once there, we can kind of do the hard work here is in this box right here is basically preparing the images for applying our models. So things like atmospheric correction, which is basically just removing the effects from the atmosphere from the imagery to what would be expected. Found lots of different atmospheric corrections. We've been testing a lot with the A6 paper that just came out, and then also with a lot of stuff we've been doing in Minnesota. They're all give different results, so they're not all the same, and some are better than others. And we found that the main atmospheric correction works best in Minnesota and for inland waters. So the other thing is cloud masking, and we basically decided to just use the cloud mask 4, but we add an extra buffer. There's some artifacts left over with that, so we have to buffer it, and then we have additional masks on top of that to clean up all the artifacts for inland waters. So with that, we were able to get some pretty good results, but we started having these anomalies. And in Minnesota, we've been getting a lot of wildfire smoke from Canada and from California. And so those were kind of affecting it. If you look at here, looks like the wildfire smoke is picked up in the terrestrial areas, but not over the lakes. So that can be real problematic for what we're trying to do. So we had to come up with another aquatic smoke mask. And so that's what we did, and we were able to take care of that. So once we have just clear pixels left, we can make some water quality models. So for that, what we did is we basically linked up all of our field measurements to all of our satellite data, and then we found the ones within, for this case, 1 day within of an image. And for SecuDisc, we had over 6,000 measurements for just in 2019. For the other years, we have over 20,000 measurements. And model developed in 2019 fits the data very well. So we have very good models. Similar thing with chlorophyll with over 10,000 measurements there. So we have some water quality models. We can make some maps and some tabular data, distribute it to different groups and put in our lake browser. So that's the stage we're at now. Hopefully by the time you see this, we'll have it in our lake browser. You can look at it there or in our temporary lake viewer that I showed you. An example of the number of data points we're able to get using this methodology. This is an example from Sentinel-2, May through October. You see, we do have good statewide coverage. There is more imagery in the overlap area, so where the blue and green dots are, than there is in the gap areas. What we have found is that we're able to do pretty much monthly mosaics on a pretty consistent basis. There will be a few gaps, but for the most part, it works out really well. And so that's our approach. We've done monthly pixel and then statewide lake level data as well. And all this data is available on our temporary website or on the lake browser that was in the URL earlier. Let's show you some examples of the water quality data that is available. So we have chlorophyll, clarity, and CDOM for every lake in the state on a monthly basis. And here's the International Rainy River, Lake of the Woods watershed up on the Canadian border, Minnesota Canadian border. And you can see a fairly pristine area, so there's not a lot going on for water quality, but this is 2019. I'm just going to go show you some examples. There's this one little red dot here that shows up for all these little lakes. There is a lot of activity, a lot of algal blooms in Lake of the Woods, which is well known. And then upper red. But for the most part, this is a pretty pristine area, just lakes and forest wetlands. And so that one dot that showed up, we took a little closer look and the imagery, and we found, yep, there was a bloom that day. So here's an example in a little bit more dynamic area. This is the Twin City metropolitan area, and then the surrounding agricultural areas around it. And this is 2019. So May, June, July, August, September, and then October. And then we will go to 2020. Very similar patterns for both of these time steps. July, August, September, lots of blooms, and very interesting. We can dig in a little deeper and do this at the lake level too. So this is at the lake level for daily time steps. So here's Lake Francis, more of a mesotrophic lake. Tatanka, which is a more eutrophic lake. Washington, Cicada, and German are all eutrophic, and Elysian, that is actually a hypertrophic lake. So all this data is available. There is if you look at this gray one here, that is actually not in the overlap area, whereas the others are in the overlap area. So you can see the difference in coverage. So still good coverage, even if it's not in the overlap area. Okay, here's another one, more of the monthly time steps. Gives you a nice graph showing the dynamic of what's going on in these lakes, and very interesting phenology for the algal blooms. We've also been having good success in other areas, neighboring states, South Dakota and Wisconsin, and then some of the southern United States like Georgia and Alabama, which is a lot more clear imagery down there, and a little bit more dynamic systems with the reservoirs due to more storm events that come in and show good pulses, which is kind of interesting to see. And then similar thing in Lake of the Ozarks in Missouri, when you see the pulses come in from storm events. Enhanced lake browser coming soon. So look forward to taking a look at that. If you get a chance, URL is down here at the bottom. With that, I have some acknowledgements, and that is about it. So enjoy the conference, and look forward to any questions you have.